Next presentation would be from Delphi TVS Diesel Systems Limited. We have with us Mr. Sundaresan and Mr. Karthikeyan, and they will be presenting us on productivity improvement in BDN nozzle manufacturing line to meet the increased customer demand. So they will be taking us through a presentation on how process modification and cellular manufacturing brought in the significant changes and improvements. Over to Mr. Sundaresan.
Good evening to all. We are from Delphi TVS Diesel System Limited, Chennai plant. Our team members are myself Sundaresan, taking care of manufacturing system engineering. He is Mr. Karthikeyan from methods engineering department. He is Mr. Tangaraj from project engineering department, and Gogalakrishnan from production department, and Giridharan from works engineering department. Our company is one of the leading manufacturer of fuel injection equipment. We are the TPM Excellence Award company. Our key customers are Tata Motors, Mahindra, Renault, Nissan and JCB. Our product fuel injection equipment consists of pump, injectors, filters and electronic control unit. Our project is related to these injectors. Injector consists of several parts like nozzle over body, spring seat, washer, etc. The fuel is passed through this feed hole and accumulated in this gallery. Then back pressure is created, which lifts the needle and spray taking place. Our project is related to this nozzle, which is one of the critical part of injector. Our problem is we are unable to meet the customer demand with the available capacity in nozzle manufacturing stream. Our current capacity is 2,800 numbers per day, but our customer demand is suddenly increased to 3,000 numbers per day from the month of October, and it has gone up to 4,000 numbers per day from the month of January 2013. There is a capacity gap around 1,200 numbers per day. To achieve the increased customer demand, we had three possibilities. We explored three possibilities. First one is make investment around 4 crores to increase the capacity and achieve the increased customer demand. But the impact is lead time for procurement and installation of machines coming around 1.5 years. Till that time, customer will not wait. So we dropped this. Our next one is run the machines for full available time, that is 24 hours into 7 days to meet the increased customer demand. But the impact is there will be increase in manufacturing cost around 1.1 crores per year. This also dropped. Our third option is import the nozzle from our collaborator to meet the increased customer demand. But the impact is collaborator stopped to produce this nozzle because this became obsolete model in their country due to revised emission norms. So we challenged this situation and selected the theme as productivity improvement to increase the capacity in nozzle manufacturing team through process innovation and manufacturing system redesign. This is coming under response to customer category. We followed lean manufacturing methodology for our project. We used certain tools and techniques like value stream mapping, takt time analysis, line balancing, design of experiments, CPK study, histogram, etc. Nozzle manufacturing has two stages. One is soft stage machining, another one is hot stage machining. The process is done before heat treatment, it is called soft stage machining. After heat treatment, it is called hot stage machining. To understand the current situation, we studied and prepared the value stream mapping. It tells clearly the material flow, information flow, bottlenecks in the flow. Our value stream starts with the customer and ends with the customer. Customer triggers the order to our PC&L department. PC&L triggers the material schedule to the supplier. Supplier supplies the material to our store. Our material flow starts from source, then it goes to soft stage machining, then it goes to heat treatment shop, then hot stage machining, finally it goes to assembly shop and to the customer. We went through each and every process and studied the cycle time, takt time, rejections, uptime and working process between each process. Then we did the takt time versus cycle time analysis. In that our takt time is 19 seconds, but our first bottleneck is electrochemical machining process, where our cycle time is greater than takt time, hence we are not able to achieve the demand. Our next bottleneck is seed forming process. Here cycle time is well within the takt time, but there is a rejection around 12%, hence we are not able to achieve the demand. Our third bottleneck is OD grinding process. Here also cycle time is well within the takt time, but there is a rejection around 7%. Our fourth bottleneck is ID grinding process. Here also cycle time is within the takt time, but the uptime is very high. Our uptime is very low, 75% only. For that we identified non-value activities in our present manufacturing system. We observed more working process, more material movement, more operator movement, and also manufacturing lead time is also very high. And also there is a lack of communication, that is a lack of information flow between assembly to machine shop, and also more supervision is required to monitor our production. Hence there is a need to revisit the existing layout to eliminate the non-value added activities. Based on the value stream mapping, we identified 5 themes for our project. First one is to reduce the cycle time of ECM process to less than takt time. Second one is to reduce the seed and wash rejection in the internal seed forming process. Third one is to reduce the rejection due to seat to shoulder height variation. Fourth one is to increase the uptime of ID grinding machine, and finally to improve the current layout to eliminate non-value add activities in nozzle manufacturing line. First theme is to reduce the cycle time of ECM process to less than takt time. Let us understand what is ECM process. Internal gallery of the nozzle is formed by using this process. It consists of machine bed. At the top of the bed, electrode is fixed. At the top of the electrode, nozzle is placed upside down. Nozzle is connected to the anode. Electrode is connected to the cathode. When the sodium chloride is used as an electrolyte, when the current is passed, metal removal takes place by means of erosion. We have generated various ideas to reduce the ECM process cycle time. Our first idea is increasing the conductivity of electrolyte to reduce the ECM process cycle time. Here we have conducted many trials, but we are unable to meet the gallery specification. Then this idea is dropped. Our next idea is increasing the flow rate of electrolyte. Here also we conducted many trials between 10 to 15 bar. This idea is also dropped because electrode short circuited. Our third idea is increasing the specific gravity of electrolyte. Here also we conducted many trials, but this idea is also dropped because excessive erosion leads to rust in the product. Our fourth idea is reducing the metal removal time in ECM process by introducing rough gallery forming operation, previous machining process. This is one of the key innovation what we have done. Here we have met the specialty specification. Our nozzle soft stage machining consists of blank tanning, feed hole, ECM forming, seat forming and heat treatment. This blank tanning operation, for that we are using CNC machining center. In this operation we have added the pre-gallery forming operation. First blank turning operation is carried out in this machine. Then we have introduced a miniature form tool which has got the dia of only 5 mm. It is used for making this gallery. This is one of the critical parameter. The diameter of the gallery is 7 mm, plus or minus 0.1 mm specification. After implementing this key innovation, we checked the quality gallery diameter which is well within the specification, and also CPK is coming around 1.42. Then again we did the takt time versus cycle time analysis. Our first bottleneck ECM is eliminated. Our cycle time is reduced from 26 to 18 seconds, but there is a slight cycle time increase in blank turning operation. That is also well within the takt time. Our next bottleneck is seat forming process. Our theme is to reduce seat unwashed rejections in seat forming process. The average rejection is coming around 12%. Let us understand what is seat unwashed rejection. There is an unclear portion observed internal seat of the area is called unclear seat unwashed rejection. Let us see the video clipping. Here product is loaded in the picture and seen in the monitor. This is the seat unwashed area. This is we are doing 100% inspection. Then we conducted the CPK study for seat to shank concentricity. It is coming around 0.82. This process is carried out in CNC turning center. We checked the YOK condition of the machine. All the parameters are well within the spec. Then Y concentricity variation is high in the seat forming process. Here the concentricity is checked with respect to seat and shank. The specification is 40 micron max. This checking is carried out after internal seat forming process. Before that we are doing blank turning operation. Here 3-meter rod is fed into the machine and turning, ID and parting operation is carried out. Here concentricity is measured with respect to OD and ID. Specification is 30 microns. With reference to this OD, the product is loaded in the chuck of the internal seat forming process. The variation in this process affects the seat to shank concentricity variation in seat forming process. This is because blank turning is carried out in separate process, seat forming is carried out in separate process. Our key innovation is to combine the seat forming and blank turning operation in a single setup. Next. Our key innovation is to combine the seat forming and blank turning in single setup. Here there are 4 processes. Before improvement there are 4 processes. Now we combine the seat forming process with the blank turning operation. Next. To combine the seat forming and blank turning operation, we have done some modification in the machines. We provided additional tool post and also we introduced a through coolant system with 40 bar pressure provided for better burr evacuation. Then we checked the results. Before improvement it was only 0.8 CPK. After improvement we achieved 1.71 of CPK and 100% inspection also eliminated. Before improvement our rejection was 12%. After improvement it is only 0.8% rejections, and also we saved 3 manpowers because of combining the operation, and also we eliminated 2 machines which is surrendered for our projects team. Now the seat forming process bottleneck is also eliminated, but this operation totally eliminated, it combined with the blank turning operation. But there is a slight cycle time increase in this operation, that is also well within the takt time. Now our third bottleneck is OD grinding process. I request my colleague to continue the presentation.
Our theme 3 is to eliminate seat to shoulder height variation in our OD grinding process. This is our rejection trend. Our average rejection is 7%. Let us understand our OD grinding process. It's angular plunge type grind. Grinding takes place in the entire OD of the nozzle body. Back chamber, shank, shoulder, head and front chamber of the nozzle body will be formed by the single plunge of the grinding wheel. To understand the issue, we conduct a process capability study for this parameter and we got CPK less than 1. To understand the issue, we checked the YOK check. In that we found two abnormalities. One is component clamping issue, another one is wheel head slide repeatability issue. For component clamping repeatability issue, we modified the locating mandrel tip angle. Before the mandrel makes full contact with the nozzle body, after the mandrel makes single point contact of the nozzle body. For wheel head slide repeatability issue, we converted the wheel head slide from hydraulic system to servo system. Even after implementation of the above actions also, our seat to shoulder height variation is in the same level. So we generated various ideas to reduce the variation in our grinding process. We generated 3 types of ideas. We conducted 3 trials. In these trials, we unable to get positive result. So hence we dropped these 3 ideas. So we made analysis in our OD grinding process. From that we found the following points. Shoulder and chamfer of the nozzle body will be formed by the single plunge of the grinding wheel. Any variation in one dimension will affect another dimension. Unable to correct the dimension independently in this machine, and we don't have linear axis in this machine also. To eliminate the above listed constraints, our team discussed it together and we decided to introduce hot turning process. This is our implemented hot turning process. Generally, the turning process will be done for the shaft component. Here we implemented this process for hot stage component. We developed on locating mandrel. In the mandrel, we have one orientation pin. This pin will give drive to the component. The same setup available inside the machine. This is our loading setup. After loading, the turning process will take place. During the process, by using a single point turning inside, we are turning the entire OD of the nozzle body. In this system, we can able to correct the dimensions independently. For this operation, we converted 2 CNC turning centers from our nozzle shaft stage. We got these 2 machines by our previous implementation of single setup. We converted these 2 CNC centers for our hot turning process. After implementation of this process, we again cross-checked the process capability study. In that we achieved CPK greater than 1.8. So our 100% inspection of this parameter also eliminated. By the implementation of this action, our rejection in OD grinding was reduced from 7% to 0.1%. So our OD grinding rejection issue was eliminated. Our next issue is ID grinding uptime issue. Our theme 4 is to improve the uptime of ID grinding process. Grinding of internal bore and seat of the nozzle body to the accuracy of 0.5 micron roundness is our ID grinding process. This is our ID grinding machine. This is a precision ID grinding machine. High frequency spindles are used at an RPM of 1 lakh RPM to grind the components. This is our uptime trend. For that we made a Pareto. In that Pareto, we observed work at bearing failure is the #1 phenomenon. One time of work at bearing failure will take 20 hours of MTTR. This is mainly due to the design of the work at spindle and critical of the process. For spindle bearing failure, we made analysis. In that analysis, we found 2 causes. One is coolant entry into the work head. Another one is incoming air cleanliness level. For our cause 1, we are using grinding coolant at a pressure of 2.5 bar. During the process, the coolant enters into the work head. To avoid that, we provide a air bracket around the work head. From the air bracket, air will flow. This air will oppose the entry of the coolant. So our first cause is eliminated. Our second cause is incoming air quality issue. Currently, we have air quality of class 4. Our idea is to improve the cleanliness of air level. For that, we made some modification in our air treatment method. Before, this is our air treatment method. From this method, we achieved incoming air cleanliness level as class 4. After that, from the air compressor, air goes to a reservoir, then it goes to after cooler, then it goes to moisture filter. We converted this filter into 2-stage filter. Then the air goes to oil filter. We converted this also 2-stage filter, then IHR dryer. Finally, the air enters into the machine shop. By the implementation of these points, our incoming air quality we achieved as class 1 level. This is our compressed air treatment method in our company. By the implementation of this action, our average uptime in ID grinding was increased from 75% to 98%. So our ID grinding uptime issue also eliminated. Further presentation will be continued by Sundaresh.
Our final theme is to improve the current layout to eliminate non-value-added activities. This is the present layout of nozzle manufacturing. Its flow starts from source to soft stage machining, then it goes to heat treatment shop. After that, it goes to hot stage machining. Here, all the machines are placed inside the air conditioned room to maintain the sub-micron level tolerances. Here, we are following the process type layout. Machine that performs similar processes are grouped in one area. For example, OD grinding are grouped in one area, ID grinding machines are grouped in one area, like that it is grouped, and more WIP is maintained between each process to make the continuous flow. After hard-side machining, the product goes to assembly shop. To eliminate the non-value added activities, our team decided to introduce a cellular layout. One of the key elements in cellular layout is product grouping. Here there are 5 part numbers which is grouped as 2 product family. One is commercial vehicle product family, another one is passenger car product family. Then we allocated the equipment based on takt time and cycle time to each product family. We have not added any new machine, only inspection gauges we have duplicated. This is the proposed layout concept. Here we have not made any changes in the soft stage and heat treatment. Hard stage machining is divided into 2 cells. One is passenger car product cell, another one is commercial vehicle product cell. Here according to the sequence of the process, machines are placed. Only one inventory point. Between each process, single piece flow is maintained. From passenger car product cell, the product goes to passenger car assembly line. From commercial vehicle product cell, it goes to a commercial vehicle assembly line. Like this we aligned the cells. This is our implemented layout. The main feature of this layout is we removed a coolant, chillers and mist collector from air conditioned area to non-AC area, which resulted in substantial reduction in heat load, resulted power cost reduction, and also dust and mist free environment for operators. Then we did the line balancing activity. Purpose of line balancing is to leveling the human workload across all the process. Here we did the line balancing with respect to takt time. For CVBU cell, there are 2 operators who runs 6 machines. For PCBU cell, there are 8 operators who runs 3 operators who runs 8 machines, and our line balancing efficiency is 88%. Previously it was only 60%. With all these improvements, we achieved the following results. We have done 5 key innovations in this project. During start of the project, our capacity is only 2,800 numbers per day. After implementing ECM cycle time reduction projects, our capacity went up to 3,300 numbers per day. After reducing rejection in C10 was rejection, our capacity gone up to 3,500 numbers per day. After that, our OD grinding CPK improvement takes place. From that, we achieved a capacity of 3,800 numbers per day. After improving the uptime improvement, we achieved 4,000 numbers per day. After implementing the layout, output is increased, capacity is increased to 4,200 numbers per day, and consistent output is achieved. Our productivity improvement is 37%, and also we are able to meet the customer demand 100% with the minimum resources. These are our financial benefit. Due to rejection cost saving per annum is 39 lakhs, reduction in manpower cost saving is 40 lakhs per annum, reduction in power units cost saving per annum is 72 lakhs, reduction in WIP, the cost saving is 2.4 lakhs per annum, and also total cost saving is 151 lakhs per annum, and also there is a capex saving around 400 lakhs. Amount spent for this project is only 6.5 lakhs. Then to sustain the result, we standardize the improvements through document updation, and also we horizontally deployed the hot turning process to our pump delivery valve manufacturing. Our future plan is to increase the capacity of nozzle from 4,200 to 5,200 numbers without investment. Thank you.
Thank you.
Very well made presentation with your continuous flow of information. You could meet the timelines also very well. Yeah.
Exactly 20 years, sir.
Yeah. Still 1 more minute is there. Yeah. So over to the jury for questions.
For our question and answer, we will welcome our team members.
I'll call my team members.
Yeah, please go ahead. Yeah, over to the jury, please.
Yeah, we appreciate your very detailed and structured presentation. Good job done. Now you have made so many changes in your process. So any FMEA analysis done to on the new process?
Yes, sir. We have done this. You can explain.
Yeah, we have done FME analysis for every
Sound is out.
Yes, we have done the FME analysis for the process change. From ECM, we have done for the pre-gallery introduction, we have done the process FMEA.
So can you just highlight 1 or 2 things as a result of FME analysis you made some changes?
Actually, if the pre-gallery dimension, the final spec is for the ECM gallery is 8 mm, and we have maintained the pre-gallery dimension 7 mm. So that 7 mm the tolerance of 50 micron. So we have to maintain that. For that we have developed a view scope with the available facility to check the gallery dimensions. So that will give the exact gallery dimension after the ECM process. So we have made that according to the FMEA.
And this, you said proposed layout. Is it that the new layout is yet to be implemented, or
We have completed the layout activity, sir.
you have completed the layout?
I presented in that results, which time we have implemented April, during the month of April.
Okay, good. Thank you.
Thank you for your outstanding work. I'm sure your company must be very happy with you for what you have done. Have you all lost your job, or you got a promotion? Anyway, very, very happy to see a variety of things done. You got a couple of cases of rejection reduction, one case of process itself being changed in the ACM, uptime improvement, and layout improvement. So it's a combination which is working. So it's a very composite application case. I appreciate that. Just a couple of points. First, a very small point. The fault tree analysis that you have shown is only a tree diagram. It's not a fault tree analysis, right? You understand what a fault tree analysis is? Or if not, you can learn it very easily. Because a fault tree analysis involves AND gates and OR gates, and it's a good tool for you to learn in some of these situations, especially if you're trying to improve uptime and so on.
Yes, sir.
The other thing that worries me is your CPCPK calculation. Do you realize that presenting CP without a control chart is utterly meanissless?
For that constant decision.
Do you understand that,
Yes,
or you
sir,
don't
yes, sir.
understand? Why have you not presented the control chart but only the histogram? It makes no meaning.
Sir,
You want to answer that?
Sir, we have taken the data which capturing the time to time variation also, sir.
You're
So
not
we
answering
have
my
taken
question.
from that PMC
You're
chart.
not answering my question. You worry me even more if you say like that. Do you understand why? Or you don't?
Yeah, can you
Control chart.
You did your CP calculation without a control chart?
So in our factory, we are maintaining a process monitoring chart for the every dimensions. From this dimension, we are calculated the CP and the CPK also. And the CP is present in the all operation are well within the spec. Only the
not answering my
CPK is the
question.
minimum.
Did you make a control chart? You didn't make a control chart.
Yes, sir, we making it.
So what control chart did you make, and why are you not showing that?
Because of time constraints.
Okay. If you look at your rejection rate, you're saying CPK is 1.71, rejection is 0.8%. Now, if that is true, that means you're getting abnormalities. And if you're having abnormalities, you have no business to be calculating CPK. You should be addressing the abnormalities first. But you don't have the control chart to show your abnormalities. So are you having abnormalities? Or you don't know you're having it or not?
There is no abnormalities.
No, we don't find any abnormalities.
So please do this a little properly. It worries me a lot because you have done otherwise so much of good work. But if you're going to do such a thing, then you're going to be in trouble sooner or later. Okay?
Yes, sir.
Thanks.
Control chart. PMC.
Yeah. So, other questions from the delegates? Please.
Have you done the product endurance testing? What is the specification? How much you are achieved? Question number 1. Question number 2. Pre-gallery introductions. Your CPK it is 1.42. I think specification your company it is minimum 1.66. I think. So, do you have any action plan? How to improve the tool?
For the first question of the endurance test, actually we didn't make any change in the product. The process we have changed. So we have testing process in the assembly line. So we have tested the, initially we have tested with the control batch and we have uploaded with the quality reports. Based on that we have implemented the layout with the process change request, with the process change request. For the second question?
Pre-gallery introduction in the turning process. Your CPK it is 1.42.
Yes, sir.
Minimum specification it is 1.66, right?
For the dimension, actually the tolerance is open. So we have considered for 1.33 is okay for that at that moment. So we are improving on the tool side to bring it back, bring the CPK level above 1.67. So we are working on that.
In In the presentation you are mentioned this is the very critical operations.
Yeah, actually in that gallery we have ECM process after the pre-gallery. So we can able to achieve that gallery dimension after the ECM process. So we have measurement the both pre-gallery stage as well as in the ECM stage. So for that, to maintain that pre-gallery within the tolerance, we are 100% checking the gallery dimensions with the view scope. So we will be getting it through, means the dimension will not be get affected in the ECM process. So we are checking it 100%.
Well, thanks Delphi TVS team for the excellent work.
Thank
Big hand.